Welcome to our channel. In this session, we will discuss A star search algorithm in artificial intelligence. First of all, what is mean by A star search algorithm? And we will implement this A star search algorithm with one example. Simply, A star is an informed search algorithm. What is mean by informed search algorithm? Instead of blindly expanding the nodes, here they expand the nodes based on some heuristic values. That is an informed search. So A star is also an informed search, and the main goal is to find the least cost path to the goal. That is, from the start node to goal node, assume multiple number of paths are there. Among all the path, you need to calculate the path which has least cost. For such type of problems, we are using this A star algorithm. Now, what is the function that uses? The function that is on which node you need to move calculates based on g of n plus h of n. What is mean by g of n? For example, right now I am at start node S. Suppose I am moving to node n. So g of n specifies the cost from the start node to node n. So this cost is g of n. Now, what is h of n? For example, here is the goal node. The cost from n to g, and especially this is the estimated cost, not the actual cost. Understand the difference? G of n specifies the actual cost, that is from S to N. H of n specifies the estimated cost from that particular node to goal node. The estimation is called heuristic. And now what is f of n? The total estimated cost from S to N and N to G. So based on this f of n value, we are selecting the node, that is in which node you need to explore. Generally, the f of n with the lowest to f of n is considered. Now, we will discuss the A star algorithm. Here for simplicity, we are maintaining two lists. One is open and another one is closed. Okay, initially I have two lists. The open is used for storing whatever the nodes that are under processing. The closed list maintains the nodes that are already completed. So initially open and closed are empty. So in the first step, the starting node is placed in the open. Whatever the starting node, that node is placed in the open and closed is empty. Now, suppose the open consists of some node. Open consists of some node. Among the nodes, assume here the open consists of A, B, C at some iteration. Anyway, initially it has one node, starting node, assume S. After some number of steps, S is explored into A, B, C. So, A is one node, B is another node, C is another node. These are the branches from S to A, S to B and S to C. Now, what is the thing? You need to calculate f of n for all the three nodes and select the node which has the minimum f of n value. That is, among these, pick a node that has the smallest f of n value. So here assume my n is equal to b. That is, I picked the node b. If b is the goal node, B is the goal node. That means I reached the goal. Then what happened? Solution. You got the solution. Simply return the solution. Suppose you are selecting B and B is not the goal node. What you are doing? Simply again expand the children of the B. Here expand n means generate successor. Successor means generate the children of B. For example, the children are X, Y, Z. So for each successor, yes. So yes, in the sense, suppose here use the term small as simply some common name. Again, same thing. For each successor, you need to calculate G value, H value and F value. That is, you are calculating the heuristic value. And after calculation, if S is not in open or closed, that means till now you are not placing anything, add X to the open list, add Y to open list, add Z to open list. Suppose here the most important point is, if a node after expanding, understand carefully, B is expanded to XYZ, but right now not at all placed in the open. Expanded, I am calculating all the values for XYZ, and if any node is not in the open till now, simply add that node. Suppose assume the open list already consists of a value X. Now I am getting one more X. Now what happened? That is, if the node is already open with the higher cost, here this is the lower cost, then immediately you need to update. So the process is repeated. The same process is repeated. Finally, if the open is empty and the goal is not at all available, the output is a failure. That is, the goal is not at all available. Clear the point? Now, whatever we discussed this point, this is the most important of A star algorithm. We discussed the same thing in an example also. Okay. Before going to the example, what are the main properties for deciding any algorithm, whether it is the best or worst? Based on these properties, complete means always the A star algorithm produce some solution. Optimal, if the you are selecting the best heuristic value, it always gives the optimal solution. Time complexity means you need to expand multiple number of branches. So obviously we have an exponential time complexity. Space complexity, you have multiple number of nodes. If you have multiple number of nodes, in the sense, obviously more number of memory is required. Now this is the example. Now we will discuss this example in detail. We'll discuss this example in detail. Okay, this is the example. Now what are the step by step procedure? Coming to the first step, what is my first step? Initialization. So here in this example, choose any one node. Here my chosen node is yes, so I am choosing node yes. Now immediately my open consists of node yes. My open consists of node yes. Here a node is represented in the form of G H F for easy calculation. For easy calculation. Now node S consists of, what is the value of G? G specifies the distance or cost from starting node to that node. Here S is the starting node. That node to that node, G value is 0. What is H value for S? Heuristic value, estimated value 7. Now you know the formula, simply F is equal to G plus H. This is open. Now what about closed? Initially closed is empty. Clear? This is step number 1. Now the open consists of only one node. Open consists of only one node. So simply our step is expand that node yes. Expand that node yes. Now what are the branches of S? S to A and S to B. So the branches are, one is A, another one is B. So A from the S, B from S. Now what is the value of node A? So from starting node to A, the distance is 1, that is G value. The heuristic of A is equal to 6 and sum plus 1 plus 6, 7. Now B, S to B, the distance is 4 and heuristic value is equal to 2, 4 plus 2, 6. So these are 2. Now So I am expanding, yes, understand? Now I am updating. Remember, in the algorithm also is to first you are expanding, after that check whether that is already present or not. Here right now my open consists of yes. Whenever you are expanding yes, now my open consists of a comma b and my closed consists of the node yes. The node yes. Clear? Now question is open consists of a comma b. Among these two, which node you are selected? This total value is equal to 7. This total cost is 6. Which one you are selected? You are selecting the node B. Why? B has the lowest value. B has the lowest value. I am selecting node B. Clear? Now, coming to next step. Here I will write down the next step. What is step number 3? You need to expand node B. You need to expand node B. Why I selected B? Now, what are the neighbors of B? B to S. No need to calculate S. Why? S is the already starting node. We are moving B from S only. We are reaching B from S only. Here see observe B via S only. So no need to calculate. What are the other neighbors? One is C, another one is G. Here write down C via B, G via B. Now write down the node value of C. Observe here first G value. What is the G value? The cost from S to C. S to C via B means up to B the cost is 4. Observe here up to B the cost is 4 and B to C the cost is 1. So 4 plus 1 the cost is 5 and heuristic value is equal to 1 and 5 plus 1 6. Now coming to G value. Up to B the cost is 4 and B to G the cost is 5. 4 plus 5 the cost is 9 and the G heuristic value is equal to 0 and 9 plus 0 9. 9 plus 0 9. Now my open I am expanding B and then update the open. My open consists of A with the value 167 and open consists of C with the value 516. Open consists of G with the value 909. And what about my closed? My closed consists of the value S comma B. My step 3 is completed. Now which node you need to select? Here three values, value 7, value 6, value 9. Obviously we are selecting node C. We are selecting node C. So my next step is step number 4. Step is expand C. Clear? We are expanding C value. So from C, what are the neighbors? One is C to A, another one is C to B, another one is C to G. Another one is C to G. Now step by step I will write. First I am writing C to G. G via C. Now I am moving to the node G through internal, that is the mediator is C. Now what is the value of G? Up to C, what is the cost? 5. Now 5 plus 3, the cost is 8. Now heuristic value of G is equal to 0 and 8 plus 0 is equal to 8. Now understand my open consists of, sir, why you are not calculating from C to A? Even though you are calculating C to A, here C is from B. Anyway, I will calculate. Observe here. Now, right now, my open consists of A with the value 167 and G with the value 808 and one more G also, 909, and my closed consists of S comma B comma C. Understand here? Up to here, whatever it is, a value, this is in the open, already A is in the open, and G is already in the open. Now additionally here I am adding one more G. Here I am adding one more G. Now in this step, which node you need to consider? Here the value is 7, value is 8, value is 9. So at step number 5, here I am select node A. I am selecting node A. So expand A. Expand A. Now calculate A to C. Now calculate A to C. So simply here what you are writing, up to A the cost is 1. Up to A the cost is 1. A to C the cost is 2. That is the total cost is 3. So here for node C, what is the G value? 3. What is the heuristic value? 1. And 3 plus 1 is equal to 4. This is the heuristic value. Now the question is, if you understand the algorithm carefully, already closed consists of C. Again I am getting one more value with the 3 point, with 3 comma 1 comma 4. So here what is the value of G? Previously the value of G is equal to 5. Now the value of G is equal to 3. So obviously 3 is less than 5. That is A star algorithm. Now what the A star algorithm do? Simply the algorithm update the C value and then it reopens it. The meaning is, even though C is placed in the closed, but if you remember, here C is via B. But in this step, you are calculating C via A. If you are moving to C via A, we are getting less G value. Whenever you are getting the minimum value, we need to update. Whenever you are updating, now my open consists of C with the value 3 comma 14 and G with the value 808, one more G with the value 909, and my closed consists of S comma B comma C. This is the old C. Even though this is available here, practically this is moved to open. Practically this is moved to open and A. Clear? So the only important thing you need to remember is, even though C is completed, but if you are calculating via A, the CG value is reduced. Now in step number 6, this value is 4, this value is 8, this value is 9. Obviously we are considering select node C. Now C to G. Now you are calculating C to G. That is G via C. What are the values? C via G. What are the values? Up to here, the value is 3. 3 plus 3, 6. G heuristic value is 0. And 6 plus 0, 6. Now I reached the goal node. Anyway, my open consists of G with the value 808, G with the value 909, and G with the value 606. Now which one is the best? This is the best one. That means we are stopped the criteria. My goal node is reached. My goal node is reached. Now what is the final path? If you understand carefully, the final path is C to G. We are getting G via C. But here C is from this one. From where you are getting? Via A. Now, A is available from? A is available from S. Okay? S to A. This is the final best path. Now S to A, the cost is 1. A to C, the cost is 2. And A to C, C to G, the cost is 3. 1 plus 2 plus 3. This is the least cost for reaching from the start node to end node. This is an example of A star algorithm. So here everything is clear. I will discuss one more time. Starting from one node, starting from this node, these are the paths. So I am expanding this one. Among these, select the minimum one. Okay, I select the minimum one. So once I select the minimum one, I expand these two. After expanding, check whether these are already available in the open or not. Now C comma G not at all available. So simply add to open and B is placed into the close. Again, in this C is the minimum value. Even though you are calculating C to A, no need. Why? C to A means S to B and B to C and C to A. Obviously, it increases the cost. That is the reason we are calculating only G. So, update the G value. Again, if you are calculating in this, we are selecting the node A. From node A, if you are calculating C, the cost is reduced. Whenever the cost is reduced, update the C value. That means whenever you are selecting a best path, whenever you are selecting a best one, you need to update it. This is the concept of A star algorithm. Thank you.